Kristen Atchison here, and we are talking about independent groups and within subjects designs. Both of these are kinds of experimental designs. This is our first lecture looking at this issue. This first part is going to look at the between subjects or the independent groups experimental designs. So again, first we're going to tackle between subjects, and then we'll do a separate lecture to tackle within subjects because nobody wants to watch a super long video if they can avoid it. Okay, so between subjects designs. These names are interchangeable. So between subjects or independent groups, we call them this because they are independent groups. A control group is independent from the experimental group, and we're going to look at the difference between subjects, okay? So that's where their names come from. Again, these are interchangeable. Different textbooks use different terminology, so we just want to put them all out there so that you're familiar with both of their names. So the advantages of these is we don't have to worry about practice, experience, fatigue, any of those things. So the things that we would struggle with for an order of fact, we don't have to worry about that. There's no concerns about that. They're very simple, right? So we have one group that does one thing and another group that does another thing. When we think about experiments, this is what we're thinking about, right? We're thinking about a control group versus an experimental group. This is a between subjects design. Now, the disadvantages to this design is that because we're looking at two different groups, because we're looking at the differences between individual subjects, we're going to have the problem of individual differences, okay? So the thing that makes it simple, the thing that saves us from practice and experience and fatigue is going to be its disadvantage. It's going to be two sides of the same coin, right? So because we're looking at the two groups, we're going to have to worry about the individual differences between those two groups. Those are going to be factored into the design, which then are factored into our statistical analyses. The other thing that is a problem or a disadvantage is that we need more participants. So if we need 10 data points for our control group and 10 data points for our experimental group, that's 20 subjects if we're doing a between subjects design. If we can do it as a within subjects design, then we only need 10 people. So again, we're going to need more participants to work on a between subjects design. That can be really hard with certain populations. So when I did infant research, that was a super big disadvantage. And one of the reasons we didn't do it was because it's hard to find families that are going to bring their 4 and 6 month olds into a lab to do psych studies on, right? That sounds shady. It wasn't, but it sounds that way. And so it was hard to get infants that were A, their parents would bring them, but B, that assented to participate. And so that was really hard. And so that was one of the reasons we did within subjects design was because of this disadvantage. So there's 3 kinds of these between subjects design. There's the random groups design, which is the one that you're most familiar with. This is where random assignment is happening. We have 2 forms of this. We have completely random versus restricted random, and we'll talk about those a little bit more. We have a matched group design, which we've already kind of talked to a little bit. And we have a natural groups design, which we haven't talked about. And this is going to be more of those intact groups. So this is a quasi-experimental design. It is still between subjects design. It is just a quasi-experimental, which means it's not quite experimental. We'll use the same statistical methods for it, but we're not going to be able to have that same internal validity, which means we're not going to be able to make those same kind of causal claims about cause and effect. So a random groups design, and on a completely random design versus a restricted random assignment design. Completely random is just that. So if I was making 2 groups and I had everybody flip a coin and heads was in one group and tails was in another group, great, right? It's completely random. Now the problem with that is, what if everybody gets heads? Then I don't have anybody in my tails group. Or what if most everybody gets heads and I don't have anybody in my tails group? So that can be problems. Now, if you have a large enough sample size, that's not going to happen, right? The closer you get to infinity, the more equitable that comes out. So then there's not a problem. The other kind that we can have is restricted random assignment. this is some sort of assignment. It's restricted in some way to achieve these predetermined characteristics. So most of the research that's done is often this restricted random assignment, and the predetermined characteristic they use is equating the groups, okay? So it's completely random whether you get group 1 or group 2, but we're going to make sure that those groups have equal numbers, right? So again, this equal sample size. And so one of the ways that they'll do that is they'll say, okay, well, I want a completely random, like order, like experimental, treatment, experimental, like that, but I'm going to limit it that I need to have equal numbers of those two things. And so that's one of the ways that's most commonly used to restrict the random assignment. One of the ways they do this is block randomization, and we'll talk about that a little bit more as well. So a block is a random order of all the conditions of an experiment. So if you have 3 conditions, A, B, and C, you could have a block be A, B, and C. You could have a block be B, C, A. So within that 3, it's random as to their order, okay? But, and so we have the first participant assigned to B, the second participant assigned to C, the third participant assigned to A, and then we'll start another block, right? And we'll keep generating these blocks. And we'll keep generating these random orders until the goal for each condition is met. Again, one of the ways that it's easy to do this is there's a website called randomizer.org, and it makes it very, very simple. You just say how many conditions you have, how many blocks you want, these sorts of things, and it will do it for you. So when I've done my research, that's traditionally how I've done it, is this block randomization. And that's a way to do this restricted random assignment. So again, that you're having random assignment, everybody has an equal chance of getting into group A, B, or C, but we're also making sure that group A has the same number of participants as group B, that has the same number of participants as group C. So this is how we do block randomization for restricted random assignment in a random groups design. So the advantages of this block randomization is it creates groups of equal size for each condition. That's really helpful. The other thing that it does is it controls time-related events that occur during the course of experiment. So things change over time, right? So maybe you're doing, it doesn't matter what kind of study you could be doing. You could be doing a study on anything, but when you start the study, it's 19 degrees outside, and so people are dressed very differently, and we have a different kind of air system on. Then when you finish the study, it's 105 out. And maybe those systems don't work the same way. Maybe there's a difference in the first, when you start the study, your experimenters are novices and they're not sure what they're doing. But by the time you finish the study, they're really, really experts and they really have this down to a well-oiled machine. It balances those differences across all conditions. So we have condition A, B, and C being done at the very beginning when it's 19 degrees outside. We have condition A, B, and C being done at the very end when it's a well-oiled machine and it's 105. Those things are balanced. We don't think that those are really going to affect our outcome, are going to affect our dependent variable. But again, we're not going to let anything covary with our independent variable. We're not going to allow for extraneous variables. We're going to either control them or balance them out. And this is creating a situation where we can balance those time-related changes over the course of an experiment. As with all random assignment, block randomization still balances those subject characteristics. So it's still doing its best to control for individual differences. It's saying that we're going to create, on average, equal groups. It's just adding in the additional control of controlling for, say, the subject's numbers in each group, but it also allows for this control of time-related events. So it provides more control for this study than a completely random design would. The other kind of study that we're going to talk about is the match group design. Again, we talked about this a little bit in our intro as well. These random assignment requires really large numbers to balance out these subject characteristics. So if you really want these groups to be equal, you got to have big sample sizes. Sometimes that's not possible, right? And so maybe you look at it within subjects design. But maybe you can't do it within subjects design. Maybe you have issues with practice effects or fatigue or these sorts of things. And so you really need to stay with a between subjects design, but you're only going to have a small number of people. And you want to make sure that those groups are equal on the important characteristics that you have of interest. So when these small sample sizes are available, a matched group design allows us to select one or two individual difference variables for matching. So in our intro video, we talked about matching for IQ. In your lab, you're going to match for height. These are different examples. You could match for both height and IQ. Now, granted, we start to get a lot more complicated when we do that, but that's a possibility. You can match for more than one subject variable to create more equitable groups, groups that are even between those conditions. So for the procedure for doing that is you select a matching variable. It can be any individual difference variable in which they differ or variable that you think is going to be related to the outcome or to the dependent variable. So again, maybe we think that's IQ. Maybe we think that's height. Maybe we think that's grade level. Who knows? Maybe we think it's age. So we want to make sure the ages are we're doing a developmental study. We want to make sure the ages are we have all 7-year-olds, but some of them just turned 7 and some of them are about to turn 8. And we want to make sure that those averages are really even between the two groups and that our ranges are really too even. So what you do is you measure that variable, whether it's height or age or IQ or whatever it is, and you match up pairs or triples or quadruples depending on the number of conditions. So you do pairs if you have 2 conditions, you do triples if you have 3 conditions, you do quadruples if you have 4 conditions of identical or similar scores. So your tallest people are 6'1", 6'1", and 6 foot. Those are the 3 tallest people. Well, those 3 people will be a match, right? And within that match of our 6'1", our 6'1", and our 6 foot, we're going to randomly assign those participants in that match to one of the 3 conditions. So it's kind of like block randomization in where that everybody has a random shot of being in each condition, but we're controlling for some subject variable, some individual difference that we think might influence the outcome of our dependent variable. And so we're using this as an additional way to control for those things so that we have better internal validity, so that we can say, no, it is my manipulation of the independent variable that caused this change on the dependent variable. Because at the end of the day, that's our goal. So the important points about matching are that participants are only matched on the matching variable. So while we will have really equal groups on IQ if we're matching on IQ, or height if we're matching on height, the participants are going to vary a bit on other things, right? So there's still going to be variability between the group. And these could still contribute to alternative explanations. And so again, we have to pick those matching variables very carefully and make sure we're matching for the things that need to be matched. Now, you could always just add another subject characteristic, right? And match on that too. The problem is the more of these characteristics you try and match, the harder it's going to be to match. So say you're matching on height and IQ. Well, great. Okay, so I've got my 3 tallest people, 6'1", 6'1", and 6 foot. Within that, I have 3 very different IQs. I have my highest IQ, I have my lowest IQ, and I have an average IQ. Well, what do you do then? Then you need computer programs basically to help you match them after that, to really make sure that you're getting the most equitable groups across multiple variables. So we're really not going to go into the intact groups designs, those natural groups design much, because again, those are really quasi-experimental designs. And that's a whole separate chapter in your book. So this is going to end our conversation about between subjects design. Our next part on this independent versus within will be our within subjects discussion and our wrap up of, well, which is better? Thanks.